Okay, for the slope, midpoint, distance foldable, using coordinates to find those foldable, you're going to need your notebook, you're going to need scissors, glue stick, pen pencil writing utensil, preferably a colored, multicolored pen or colored pencils, but again, you could just use pen or pencil, and maybe your calculator. That's what you'll need, and we're doing this foldable right here. In just a second, I'll show you how to set it up. Alright, so to actually fold this up, what you're going to do is take this left-hand side, you're going to fold it all the way over to this line, make it a crease, and then you're going to cut on the dashed lines. You're not going to cut both the top and bottom flap, you're just going to cut the top flap on the dashed line. Alright, so you have 3 flaps, something like that. So what I want you to notice is I put up here on tape a little number line. If you have trouble with positives and negatives, you might want that for this foldable. You have to know the distance between numbers in order to do the way that I do it. Now, if you know another way using a formula or another way an old teacher taught you, please do that. My way is just makes sense to me. So if it doesn't work for you, whatever you can do to find slope, midpoint, distance, or length, that's fine. But this is the way I like to calculate this. So let's open up slope. Slope is how a line moves up or down and left to right. Very often in math we use smaller case m for slope. If you remember y equals mx plus b, m stood for the slope. It's rise over run, so it's how it changes up and down over how it changes left to right. Some people call this delta y over delta x, change in y over change in x, things like that. Rise over run. Just so as a reminder, or maybe this is new to you, parallel lines have equal slope. So if lines have this same m value, then they are parallel. Perpendicular lines, or lines that meet at 90-degree angles, have negative reciprocal slope, which means that you would flip the fraction and change the sign to have the perpendicular slope of a given line. So for instance, 2 over 3, the reciprocal of that is negative 3 over 2. As another example, let's start with a negative 1 over 4. If you flip it and change the sign, it's 4 over 1 or just 4. Okay, so those are negative reciprocals. So I'm going to do one example, and then I'll leave the other one for you to do. So here's how I calculate slope. So if we want the slope between A and B, what I do is I put A here, so negative 4 comma 2, and then B is negative 2 comma 8. Okay, so first we're going to find the distance between the x values. So negative 4 to negative 2, you got to go up 1, 2. So up 2. From 2 to 8, so 2 to 8, we got to go up 1, 2, 3, 4, 5, 6. So up 6. So the slope would be the change in y, so that's this side on the right, so 6 over the change in x. Okay, so over 2. So the slope between those 2 points is 3 over 1, or just 3. Alright, so midpoint, that's this middle flap here. The midpoint is exactly halfway between 2 points. It splits a line segment into 2 equal parts. Now there is a formula. It's right there. I don't typically use the formula. I do it a different way, but if you want the formula, there it is. You add the x values, divide by 2. You add the y values, you divide by 2. Though that would be the coordinates of the midpoint. If 2 lines have a common midpoint, so if they have the same x comma y coordinate for a midpoint, then they bisect each other. Alright, so here's how I calculate midpoint. So I start with A, alright, so 6 comma 8. Then I have a point for my midpoint, so I'm going to call that M, midpoint. We don't know what that is. And then B is negative 2 comma negative 4. Alright, so we're going to find how far is it from 6 to negative 2. Okay, 6 to negative 2. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8. So down negative 8. Now, because we only want to go halfway, because it's the midpoint, half of negative 8 is negative 4. So we're going to start at 6, go down 4, So 6 minus 4 is 2. Right, now let's do the same thing to the y values. 8 to negative 4. So 8 to negative 4, we'd have to go down 12. So down 12. Now that's the whole way. We want to go half of that. So half of minus 12 is minus 6. 8 minus 6 is 2. So the midpoint between A and B is at 2, comma 2. Alright, so for the distance one, we open that up and it says distance or length is how long a segment is on a coordinate grid. The traditional formula comes from the Pythagorean theorem, a squared plus b squared equals c squared. If you actually want the formula for distance, it's d distance equals the square root. You ready for this? The 2x value subtracted and then squared, added to the difference of the y values, also squared, and then you take the square root of that. So there's the formula. I don't use the formula. I find it kind of confusing to use. Let's take A at negative 4, 2, and B at negative 2, 8. We're going to find the distance between the x values. Alright, so the distance between negative 4 and negative 2, so we're going to go up 1, 2. From 2 to 8, so 2 to 8, we're going up 6. Okay, now what we're going to do is we're going to put those into the Pythagorean theorem. 2 squared plus 6 squared. So 2 squared is 4, plus 6 squared is 36. That's 40. And then we're going to take the square root of 40. This is where you might want your calculator. You might also want it for the 2 squared plus 6 squared. But in any case, second square root 40. And let's round to the nearest tenth, about 6.3. Now I want to show you why that works. Okay, so on this grid, I have A at negative 4, 2, B at negative 2, 8. This 6 right here is actually the change in y, so it's how far A and B are apart going up and down. This 2 is how far apart they are going left to right, so it's only 2 apart. What we're finding is the distance between A and B. If you actually connect all of those, you can see that by connecting the change in y over and the change in x and the distance between the two, we make a right triangle where this change in y and this change in x are the sides of a right triangle. So that's why we can put 2 squared plus 6 squared, excuse me, and if we take the square root, we get the length of the hypotenuse. So it really comes back to right triangles and the Pythagorean theorem to find distance. So now what I'd like you to try to do is go back through and try these other examples. Okay, and what I'll do is what you could do is maybe pause the video and then come back, and what I'll do is just kind of put in the answers that you should get. If you don't get the same answer, yeah, that's fine. Just maybe put an X through it, and that's something we can go over in class. All right, so here are the examples that I hope you worked through. For the slope between C and D, I got negative 1/3. For the midpoint between C and D, I got 2, 2. And then for the length down here, I got about 3.2. Now one note down here is that if you're using your calculator, make sure that when you type negatives into the calculator and you square them, you want to put the negative number in parentheses with the exponent on the outside. If you don't do that, you're not going to get the right answer. Let me show you. It should be 10. 3 squared plus negative 1 squared gives me 8, and that's because it does that negative 1 squared differently when it's in parentheses than when it's not. So if you want to square or raise exponents to a power, make sure it's in parentheses on your calculator.